So, hello everyone, and welcome to my talk about rapid server-side full-stack web development with ViewComponents and htmx. My name is Thomas Schuehly, and I'm excited to be here as this is my first conference. I'm 22 years old, and I love to build awesome stuff with Kotlin and Spring Boot. I'm blogging about it and my experiences while building applications on tschuehly.de. To keep me from sleeping until noon, on weekdays I have my dailies at 9 o'clock as a process automation software engineer at Mimacom in Germany, in Stuttgart. I'm also a freelance web developer and an open source developer. I will present you two libraries today. So, to start off, would you describe yourself as a software engineer? Give me a show of hands. Okay. So, most of you are software engineers, so I assume you all know what software is. But have you thought about the engineering part? What is engineering, and how should it affect us when building modern web applications? I neither have the experience nor the pretension to tell you much about engineering, as I've been only a software developer for a few years. So that's why I'm drawing upon the insights of Dave Farley, an expert in continuous delivery, who wrote the pioneering book, Continuous Delivery, a practice most of you use today, I think. He has a long track record in creating high-performance teams and outstanding software. As a software developer, I always looked up to him as he shares his valuable insights and his real-world experience on his YouTube channel, Continuous Delivery. He shares his point of view on engineering in his blog post, What is Modern Software Engineering? He's uneasy with the term in the context of software development, as it is either incorrectly with meaning or emptied of it altogether. Some developers think it entails stifling bureaucracy and heavy wide process control, while others think it's just simply writing code and nothing else. He tells us that both of these are profoundly wrong. In other disciplines, engineering is simply the stuff that works. It's practical, pragmatic, and more, not less efficient. But is the way we build modern web applications practical, pragmatic, and efficient? Could there not be a simple approach that is sufficient for many use cases today? The systems that modern engineers create are increasingly complex and sophisticated. Modern software engineering needs to focus us on managing that complexity. Farley concludes that if an engineering approach to software development doesn't help us to create better software faster, it is wrong and it doesn't qualify as engineering. So, did we overshoot this goal while trying to build more advanced systems than ever before to solve problems that we created ourselves? What if instead we tried to reduce complexity for our modern web applications that are not inherent in the challenges of our business, but accidental due to the nature of our solutions? Modern JavaScript frameworks were developed to manage the complexity of front-end development and improve the user and developer experience. They're mostly single-page application, meaning a blank HTML and a big block of JavaScript gets delivered to the client to render the page on the browser. The most used JavaScript framework is React, with 82% of developers who answered the State of JS survey 2020 used it. It has grown to the de facto norm for building web front ends. Here you can see what a typical single-page application render process looks like. The browser calls a JavaScript function. This function again calls an API client that fetches the data from our beautiful Spring Boot backend. The backend fetches the data from our database and then has to transform it into a POJO. The POJO then gets serialized into JSON. The API client then has to deserialize the JSON into a JavaScript object. The single-page application then needs to merge these changes into a virtual DOM, and the virtual DOM is synchronized with the actual HTML browser DOM. The JavaScript community started to question the way most modern web applications were built over the last decade. In the intro to the State of JS survey reads, after years of relative stability, many are now beginning to question the status quo. On the server, Astro, Remix, and Next.js, among others, are making us reconsider how much code we really need to ship to the client. But even if the JavaScript fanboys tell us that we shouldn't ship much code to the client, why do we need this complexity? The JavaScript frameworks come out of the box. There are certainly use cases where we need sub-millisecond responses on a dynamic UI, But does anyone think all the stuff currently built with an SPA needs one, from a user needs standpoint? Tom McWright puts it nicely in his blog post, Second Guessing the Modern Web. There's a sweet spot of React in moderately interactive interfaces, complex forms that require immediate feedback, and UIs that need to move around instantly. I agree that there are many applications that need this kind of user experience, but I think even more apps don't need this level of interactivity or could benefit from a simpler approach. The excellent engineers that contribute to the ThoughtWorks technology agree. Single-page applications are an architectural style that should be chosen after proper trade-off analysis, and for the additional complexity a single-page application implies. The problem is that nowadays this analysis is often skipped and is not evaluated if the requirements even need a framework like React. Many developers nowadays are not even aware that other possibilities exist because they spent their entire career in a framework like React. The ThoughtWorks Technology Radar concludes that many websites will benefit from the simplicity of server-side logic. Most of you that were developers before 2015 probably built web applications with the traditional approach to the web, multi-page applications. The approach is quite simple and still powers most of the web today. Instead of shipping a blank HTML and a giant JavaScript bundle to render the pages on the client, we just ship the HTML the browser can display directly to the client, and having no overhead. Spring can serve HTML to the browser directly. When a request goes to a controller, the controller then fetches the data from our database into a model. The HTML template that we create is the view, and these both are passed into the template engine as model and view that renders an HTML and returns it to the browser. Sounds awesome, right? We removed a whole lot of complexity by removing two data representation layers between our client and our data. We lost some interactivity though, because we just ship static HTML without any client-side JavaScript. So how can we return the JavaScript, the interactivity, to our server-side rendered web pages? To solve this question, we need to look at the original model of the World Wide Web and focus on the hypermedia essential to even the most over-engineered JavaScript pages. Because in the end, the browser can only display the hypertext markup language. So why not we deliver it over the hypertext transfer protocol like Tim Berners-Lee did in 1989 when he invented the World Wide Web. Hypertext is a form of hypermedia. Ask your younger colleagues if they ever heard of hypermedia. Not many tutorials nowadays cover the fundamental platform of the World Wide Web. Hypermedia is defined by the presence of application control information embedded within or as a layer above the presentation of information. What does Fielding want to tell us with this quite academic definition? When we deliver hypermedia to our clients, we also deliver the possible interactions the client can do. The most common control you probably all know is the anchor tag, or hyperlink. It enables us to discover whole applications without any documentation. Or when was the last time you had to read documentation to order cat toys from Amazon? Hypermedia as the engine of application Hypermedia as the engine of application state is a constraint of the REST application architecture that distinguishes it from other application architectures. With Helios, a client interacts with a network application whose application servers provide information dynamically through hypermedia. The REST client needs no prior knowledge how to interact with the server beside a generic understanding of hypermedia. Helios decouples the client and the server at a network level and enables us to evolve them independently. Ask yourself, do you need a lot of communication between your front and your backend through API docs if you want to evolve your single-page application? The JavaScript frontend need intricate knowledge of your backend API to render, because they need the correct information and structure to render the HTML correctly. So why decouple at an application level between the template and our data with JSON? Another interesting fact of Helios is that we don't need different roles for the client and the server, because we don't need to develop our own client. We just use the hypermedia client available to all our users without download, built by some of the smartest engineers at Google and Mozilla. We reduce the complexity immensely, and we enable backend developers to create features entirely by themselves, because hypermedia is quite a simple concept. We can fill HTML with data from our database when we deliver it to our user with Spring as well. Spring uses the model view controller pattern to server-side render applications. With MVC, the controller is responsible to receive the request. Here you can see a get mapping with the path greeting. The controller then changes our model. Here we add the attribute name Spring.io to our model. Then we return the name of the template we want to render. Here it's the greeting.html that lives in our resources folder. There are multiple template engines to render dynamic data with Spring, like Apache FreeMarker and JMustache. But today I will look at ThymeLeaf and JTE, the Java template engine. First, we will take a quick look at ThymeLeaf. It is quite simple to render some crispy HTML. This is the greeting.html we just returned from the browser. It is just box standard HTML. We add a little tag at the top so our IDE picks up the template language. To render our data, we use th attributes. Here, it's the th text attribute. It adds hello Spring.io to the inner HTML of our p tag. The name, we use the name variable from our model. We can also do stuff like iteration over a list. Here, we iterate with the th each attribute over the list of products. Then we show a table data cell for each property of the object. Conditionals are also very simple. We can use the ternary operator you might know from other languages. If the in-stock evaluates to true, we show the message not in stock. The message in stock. If it is false, we render the message not in stock. There are even more features, but I will not go more in depth in this talk. The next, we will look at the JTE, the Java template engine. It might feel more natural to Java developers, and it has an awesome plugin that makes JTE very productive. We can use plain Java expressions right inside our HTML with a $sign and a curly braces. We can either use them inside attributes or inside our HTML directly. JTE templates are compiled to native Java classes. To import the classes we use the add-import syntax. We also need to declare the parameters that need to exist in our model with the add-param annotation. We can also use control structures like ifs. Here, we check if the page description is unequal null and then show the meta tag. We can also do for loops with JTE. Here, we loop over the list of persons and then show a table header for each person property. MVC is quite simple, but it has some shortcomings that bothered me while I was building my software as a service-side business over the last year. The two most popular JavaScript frameworks were built by some of the smartest software engineers at Google and Facebook, and they built their UI based on components, because components make the UI reusable and structured. Components are so cool that even GitHub built their own ViewComponent library for the Ruby on Rails server-rendered parts of github.com. But there weren't components to create a reusable type-safe UI with Spring. But fret not, I've solved that with the Spring ViewComponent library. I can show you how we solve the issues that occur with an MVC approach. The first problem with MVC is that our controller has to have intricate knowledge of what variables we need in our template, tightly coupling your controller to our view. There are no compile time checks if the model properties are even available. This gets especially spicy if we reuse templates inside other templates. For example, if we change a variable, we need to change it in every template in every model that the controller method returns that template. To solve this, we use Spring ViewComponent. We can create a component with the add ViewComponent annotation, making it a Spring-managed bean, enabling us to dependency inject services, for example. We then define a random method that returns a view context. Here, we use the JTE-specific JTE view context. We create a hello world property and get the data from our example server, making it available to our template. Then, on the bottom left, you can see the template. It needs to have the same name as the component in the same package. Inside our template, we can then use the properties we defined in our view context. To display components, when we want to navigate to a certain route, we call the homeViewComponent.random method and return it in our controller method. We now have a clear separation of concerns. The controller is responsible for routing and not for data fetching. And the view component is responsible that all data is available at the time of render. We can also nest components to make them reusable. Here, we pass the view context that the parameter ViewComponent.random method creates to our template. Then, inside our template, we use the JTE view context inside a JTE expression. The homeViewComponent is an independent component, as it fetches the data itself, but making it less reusable, as the data source is fixed. The other type of component is the parameterized view component. It does not do any data fetching, but instead relies on the parent component to pass the data. We can reuse these components everywhere in our app and give us the ability to create type-safe templates for commonly used UI patterns. With MVC, another problem with MVC is that the templates need to live in a resources directory, while our controller lives in the Kotlin directory. We have a strong disconnect where we aggregate our data and where we use it, thus having a low cohesion, which adds cognitive load when we try to evolve our front end. With Spring ViewComponent, we can have a highly cohesive code structure, as the template needs to live in the same package as the data provider. It enables us to create a completely feature-based package structures. With MVC on the left, you can see that our slideshow feature is split in the resources directory and in the web controller package. With view components, it is nicely packaged together in a bundle, in the slideshow bundle. So why did we move away from the hypermedia model to the JavaScript dystopia we have today, if it is so simple to create HTML on the client, on the server? Because HTML did not evolve as a hypermedia. We only have two hypermedia controls, the anchor tag that enabled the fundamental model of the World Wide Web. And the World Wide Web is a hypermedia system that interconnects resources through URIs. The second element is the form element. It was introduced in the HTML2 RFC in 1995. It made transaction for the first time possible in this vast hypermedia system. But it is still the same as it was 28 years ago. But one guy in Montana and his internet friends were not satisfied with that and created a library to complete HTML as a hypermedia and compete against the giant JavaScript ecosystem fueled by big tech as we know it today. This library is called htmx, and it has gained quite a bit of attention over the last year. GitHub recently picked it up in their open source Accelerate program. In a nutshell, htmx enables us to use modern browser features without ever leaving our HTML. It makes features interactive without ever needing to touch any JavaScript. To understand htmx, we first look at the anchor element. This anchor element tells the browser that when a user clicks on it, that it makes an HTTP GET request to the /blog endpoint. We then load the response into the HTML browser window. Here's a simple example of htmx. It issues a POST request to the /click endpoint and then when the content is loaded into the content of the response is loaded into the ID with the parent div with the hxTarget attribute. We then swap the outer HTML, so we swap the whole element. htmx has sensible defaults. Here, the hxTrigger attribute is not needed as it is the standard behavior for a button element. htmx extends and generalizes the core idea of a HTML as a hypertext, and adds many more possibilities directly within the language. We enable developers to easily create a full-stack application, because now any element, not just anchors and form, can create HTTP requests. Now any event, not just click and form submission, can trigger requests. Now any HTTP verb, not just get and post, can be used. And now any element, not just the entire window, can be targeted for updates. htmx refers to this style of application as a hypermedia-driven application, or HDA. It tries to capture the advantages of both a multi-page application and the simplicity and flexibility of it, with a RESTful application architecture, and hypermedia as the engine of application state, with the superior user experience of a single-page application. htmx enables us to enable UX patterns that are only commonly known with single-page applications, like active search. This input triggers a post request to the search endpoint on key up that is debounced by 500 milliseconds. Then the response is swapped into the search results element. Here's an active search example on htmx.org. It has the same experience as a single-page application without any of the complexity. You can see the essential characteristics of a hypermedia-driven application. Our front end is entirely specified in declarative htmx attributes right inside our HTML. As you can see, the interaction is done entirely over HTTP and HTML. htmx makes requests for us and swaps the HTML that gets returned into the DOM. It is not a far-fetched idea to think that if HTML would have evolved further as a hypermedia, that this could be native HTML enabled by our browser. As with everything, there are advantages and disadvantages we need to consider when engineering our software. Hypermedia-driven applications are especially good if your UI is mostly text and images, for example, a news article site that serves media to our users. Here's a real-world example of htmx. It's the software as a service startup context. They track legislation in the French Senate and show amendments. They transitioned successfully from a Django plus React application to a Django plus htmx application. If your UI is nested and the blocks are well defined, it is easy to create dynamic interaction. This lends itself especially to the view component approach, as we can just re-render our components on demand. We get out of the box first page render performance that is perfect, and search engine optimization, as it is just standard HTML. As I've alluded to earlier, there are use cases where a JavaScript-centric approach makes more sense if we need a high degree of sub-millisecond interactivity, for example, Google Sheets. Now, I've talked why and how we can create a hypermedia-driven application, but what should not be overlooked is how the team structure can change if we radically simplify our web development approach. When Context was using React, they had a hard split between back-end and front-end developers. 2 developers were entirely back-end, 1 developer was entirely front-end, and 1 was full-stack. After the port, the entire team became full-stack developers, except the JavaScript developer. He didn't have a job anymore. Each team member is more effective and able to contribute more value. The development is more fun, as they can own an entire feature. It leads to better optimized software, as they can make optimizations anywhere across the stack, without any coordination. Spring ViewComponent nicely integrates with htmx. In this example, I created an analytics service that measures the render time of each view component using the aspect-oriented programming support of Spring. We want to show a chart for each component to our user. Obviously, we don't want any reloads for a nice user experience. I've created the analytics chart view component that auto-wires the analytics service. We then create a chart with the generic chart view component that wraps the chart.js library in a type-safe envelope. As you can see, the view component self-describes the API through the chart details class. We can see what chart it is. We can specify the width and the height, the name, the data, and the data for the labels, and the labels for the data. Next, we look at the dashboard view component. We get all components by name from our analytics service as component label list, and then reference each component by name. In our HTML at the bottom, you can see that we loop over this list with the th each attribute. We set the button text with the th text attribute. Then, with the th hx-get attribute, we can create GET requests to our /line chart component endpoint. We pass the request parameter name with the variable name. This creates GET requests to this endpoint. To need to know what HTML should be swapped, we add the hx target attribute with the line chart ID. We then add an hx trigger attribute and add it only for the first element, that the first element loads on page load. We then create a component controller. This auto-wires the analytics chart view component, as it is just a Spring Bean. Then we create a get mapping /line chart component and add a request parameter name. Then we return the analytics chart view component .random method with the name as parameter. This is the example implemented to show you the fully interactive application without any page refreshes. As you can see, the user can just click on a button and the data updates automatically. And it also works across page reloads, so you can see that there are new data points after reloading. Next, I will show you how we can leverage Spring ViewComponent to create highly cohesive and loosely coupled features. In this example, we want to enable our user to save a person to our database. On the right, you can see the person form view component. We create the person put variable with our API config. Then, below, you can see the person form DTO. This describes the HTML form you can see on the top left. The form is defined. Then we add an hx-put attribute where we put the person put as variable. Then below, you can see the input fields that match the DTO class in our view component. On the bottom left, you can see the person controller that is responsible for saving the person when submitting the form. We reuse our API config with the person put in our put mapping. We don't care if the path changes, as it still works. The person form view DTO is our method parameter. So if we change the form and the DTO, the controller doesn't care because it doesn't own the class. When we save the person to with the person service, we use the person form DTO.convertPerson method. So when we convert the person DTO to our person domain object, the dependency only points inward, enabling us to create features in a clean architecture style. Then we return the toast view component.random method. Shows a message to our users that he saved a person. The message successfully saved persons for 2 seconds. That's another good example for a reusable view component. We can further improve the interactivity of our hypermedia-driven applications with the optional constraint code on demand of the REST architecture style. We embed JavaScript right inside our components to enable client-side interaction, but we satisfy the locality of behavior design principle. This is the HTML of the toast view component we used earlier. we embedded JavaScript with a little script tag that gets auto-executed when we return the HTML snippet from our server. In this example, we use the setTimeout function that sets the style.display element, style.display attribute to none after the duration we pass to the method. We show the message with the th-text attribute, and we enable our users with the onClick to faster hide the message. We can use vanilla JavaScript for client-side interactivity, but I've really liked the approach of the Alpine.js library. It is a minimal tool to creating interactive front-end behavior inside our HTML with 14 attributes. Here's a sample view component that shows the power of Alpine.js in combination with view components. It's a reusable tab view component we can reuse anywhere across our app for switching content client-side. This is the Alpine tab view component.kt. We can see that we have a list of tabs as parameter that maps then in our view context we list these tabs to two lists, the header list and the content list. It shows the power of view components, as we can define the API of the component in our class, typesafe. The Alpine tab view component.html template consists of the Alpine.js xData attribute. We define a variable scope, and we set the open tab variable with the value set to 0 in the scope. With the timeleaf th-each attribute, we can repeat the list elements for each item in our header list, for example, here. Then, with the button element, we show the text of the header variable we created in our th-each, and then we use the th-onClick to set the open tab to the index of the element in our list. When the user clicks on a button, the open tab variable is set to the index of the element. Finally, we show the content in our div for each item in our content list. With the Alpine xShow attribute, we toggle the visibility of our header element with the header element with the same index. We set, with the th-text attribute, we set the inner HTML of our content from our content list. This example is the rendered HTML that shows the power of combining ThymeLeaf with Alpine.js. You can see that ThymeLeaf created two list elements, each with a xOnClick attribute that sets the open tab variable to the respective index in our scope. Then you can see in the content area that on the open tab equals 0, there's a style display none added, so it doesn't show, as the open tab variable is 0 and not 1. Now I showed you how to create interactive hypermedia-based web applications with Spring ViewComponents, htmx, and Alpine.js. But to further close the gap in terms of productivity, we need to address the integrations all these JavaScript frameworks provide, because they have a definite edge for smaller projects and indie hackers, as they provide integrations, for example, for authentication. They get from 0 to production much faster than we can. To close the gap, I created the superbase-security-spring-boot-starter. It enables authentication and database hosting really easily with Supabase. Supabase is an open-source Firebase alternative that has two features that are especially interesting for our full-stack web apps. The first is that Supabase offers a hosted Postgres database that we can connect like any JDBC database. Supabase also offers us a hosted go-to server, so we can move the responsibility of storing user credentials to Supabase. We can configure email authentication and other authentications really easily in the Supabase dashboards. Supabase handles verification and password forget emails, so we don't need to build that ourselves. After we include the supabase-starter, we configure the project ID that Supabase gives us. Then we need to define the anon key, the database password, and the JWT secret, so we can mint our own JWTs. This will also set up the JDBC data connections automatically and set Supabase as Spring Boot security provider. We then can configure our security right inside our application.yaml. Here, we include some endpoints that the supabase-starter automatically creates for us, but we can register any endpoint in our YAML for any HTTP method. The starter is heavily optimized for htmx, but it can also be used for JSON API. Supabase uses JWT as authentication method. So after an email confirmation or after OAuth login, we get a JWT in our URI fragment. We leverage the htmx.ajax method to send the JWT to our API/user/JWT endpoint, which then saves it into a cookie that persists it across page reloads and navigations. After setting everything up, the email registration form is easy. It's just an AJAX post attribute to our API/user/register endpoint that is submitted with htmx. The same is true for the API, for the user login. That's all that's needed for setting up authentication, just 2 forms. We can also enable other auth providers, like here we did with Google in the Supabase dashboard. To create the Google login, we just use a link that redirects to the Google login. With Supabase security, we can also create role-based authorization for any role in our role array. In our application.yaml, we can fine-tune it for any HTTP method that this role has access to. With this config, you can see that the admin role has access to the admin endpoint with the HTTP method get, and the user role has access to the user feature endpoints with the HTTP method post. The starter exposes endpoints so we can set the roles of our users and create a role management system. We can use the endpoints with the service role secret we get in our Supabase settings. Here is an example curl request so we can set the role of this user to user. We can also auto-wire the Supabase service directly. Here we set the roles of the user with the ID 1234 to admin. We can also elevate the privileges of a user with the service role secret if we set the role to service role. Then the user has the ability to elevate, to set the roles of other users. We can use this form with the elevated user to set the roles of any users. It's that simple. The Superbase-security-spring-boot-starter exposes events through exceptions. So we can use a controller advice and an exception handler to pass messages to our user. We leverage the Spring ViewComponents again, as we want to show the user a toast that the credentials are invalid and show it for 10 seconds. Here you can see how it looks when we try to log in with wrong credentials. That's it for my talk. Here you have at the top you see the demo application that I've created for today, and at the bottom you can see the GitHub repo where the code of this demo lives. I'll make a vote. Yeah, I'm not quite finished, so you can all take a look at the repos. But I want you to contribute and connect with me at tschuehly.de, where you can find all my links to all my repos and my GitHub. And try to use the library, give me feedback what you want, what issues you have, and what use cases you want to do with it, and we can connect, hop on Zoom, and discuss about it. That's it for my talk, but I have one more thing. That's standard htmx for that we see that we've seen earlier. We're using the API config with a controller method to save a person, and we use the hxput mapping in our form. But one thing I want to enable in the future is that you just have a view action. We add a method in our component, which then automatically wires the view action attribute to our method, and then re-render the component on demand, similar to Laravel Livewire. That's it for my talk. Thank you for listening, and thanks.